Okay, so continuing to talk about different ways to solve systems of equations, we've talked about graphing, but again, it can be inaccurate when we have either fractions or decimals for either one or both of our variables. We've talked about solving with substitution. When do we solve with substitution? Either when we have one variable by itself, or it's really easy to get a variable by itself, aka at least one of the variables doesn't have a coefficient. So the next thing we're going to talk about is elimination. We are actually going to eliminate or get rid of one of our variables by adding our two equations together. Before we can add our two equations together, though, we're going to have to make sure we have opposites somewhere, and I'm going to talk a little bit more about what that means in a moment. First, I want to point out, how do I know to use elimination? It is usually going to be the easiest when both equations are in standard form. If you are unfamiliar or do not remember what standard form is, please make sure and put this into your notes. Standard form means x and y are on the same side of the equal sign. So first thing we're going to do is we're going to multiply each term of the equation by a number to either get opposite x values or opposite y values. -2 and 2 would be an example of opposites. 7 and -7. We'll then add our two equations together. That will then cause one of the variables to eliminate, because as you know, when you add opposites together, you get 0. -2 plus 2 is 0. -7 plus 7 is 0. We'll solve for the variable that remains, and then our step 4 will be the same as before. So looking at this first example, there are 3 examples. They do vary in difficulty. Step 1 is very basic. 2 has a little bit more difficulty to it. 3 is going to be as hard as they come, so to speak. So number 1 here, I'm going to first label my equations, and the first step is to multiply each term by a number to obtain opposite x or opposite y values. Well, guess what? I already have opposite y values. I have a -2 and a +2, so I can skip step 1. I'm going to go ahead and add my two equations together. I'm going to jump right to step 2, so I'm going to squeak a plus sign in there. 3x plus 2x is 5x. -2 and +2 again is 0. There's nothing left. If you want to, you can say 0y. 14 and 6 is 20, but what is 0 times y? Well, 0 times anything is nothing, so that 0y disappears, and I'm left with 5x equals 20. I divide by 5, and I get a solution of x equals 4, moving down here just a little bit to save room. From here, now that I know what x is, I just did step 3. Now I'm going to plug that back into either equation 1 or equation 2 and solve for y, and it does not matter which I pick, just like before. So let's say I plug it back into 1. Then I get 3 times 4 minus 2y equals 14, which is 12 minus 2y equals 14. I'll subtract the 12 because the 12 is positive. Remember, the negative belongs to the 2y. Divide by -2, and I get a y value of -1. So my solution, my point of intersection, is the point 4, -1. Looking at example 2, again, I'm going to go ahead and check and see if either equation 1 or equation 2 have any opposites. I notice that they don't, so I am going to have to do step 1 this time. 8 and -6, not opposites. 14 and -7, not opposites. If I start thinking about my multiples between 8 and -6, the first multiple that they have in common is going to be 24. I know that in order to get to 24, I'm going to have to multiply by both the 8 by something and the 6 by something. If I look at the 14 and 7, I notice that their first multiple that they have in common is 14. So I'm not going to have to do anything to get to 14. My first equation already has it. I can multiply the second equation by a +2, and that will make this variable here -14, which is the opposite of +14. So I'm going to go ahead and do that. I'm going to multiply equation 2 by +2. Notice I'm putting the entire equation in parentheses. This is a big spot where people make mistakes. The entire equation gets multiplied by the 2, the -6, the -7, and the -10. So equation 1 I'm going to keep the same. Distributing that 2 in, my second equation becomes -12x minus 14y equals -20. Now I can move on to step 2 and add my equations. 8 and -12 is -4. +14 and -14, well, guess what? Those are opposites, so those are going to just cross out. 4 and negative 20 is negative 16. Solving for x, I divide by negative 4. They cancel here, and I'm left with x equals, my negative didn't show up very well, negative divided by negative is positive 16, then negative 16 divided by negative 4 is therefore positive 4. So there's my x value. I'm going to go ahead and plug that in to either equation 1 or equation 2. And just like with substitution, I can pick which of my equations to choose. I'm going to go ahead and plug it into my first equation 2. It looks like that has the smallest coefficient, so I'm assuming the math will be easiest there. But it really doesn't matter. So I'll have negative 6 times 4, since I found out that x is 4, minus 7y equals negative 10. Well, that means negative 24 minus 7y equals negative 10. I'm going to go ahead and add that 24. I'm running out of room. So I'm going to kind of move it up here. I know that's a little weird. It should be in my, nice straight lines. But I'm left with negative 7y equals negative 10 and positive 24 is positive 14. Divide by negative 7, and I get y equals negative 2. So my solution, therefore, for example 2 is the point, just writing it up here because I don't have a lot of space, 4 comma negative 2. Therefore, these two equations intersect at 4, negative 2. And the point 4, negative 2, remember what it means to be a solution, would work for both of these equations. I can always check my work by taking my answer and plugging 4 back in for x, negative 2 back in for y, and making sure it truly does give me 4, and making sure to do that with both equations. Looking at the final example, again, this is going to be our highest difficulty level, but I'm going to do everything exactly the same. I'm going to have equation 1 and equation 2. And now I start thinking about how do I get opposites, because I can see 2 and 3 and 4 and 5. Neither of those are opposites. Well, 2 and 3 have a common multiple of 6. 4 and 5 have a first common multiple of 20. How am I getting those, maybe you ask? Well, that's just me knowing my multiplication facts. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 3 times 1 is 3. 3 times 2 is 6. So I'm kind of looking at if I were to set out all their multiples, where do they first match? So I'm going to go ahead and say I'm going to make these 6. But remember, 6 and 6 are not opposites. So one of them has to be 6 and the other one has to be negative 6. So what I'm going to go ahead and do is I'm going to go ahead and I'm going to multiply my first equation by negative 3, because now that will give me a negative 6m. And my second equation by 2. Making my first equation, again, the negative 3 multiplies by everything. Negative 6m minus 12n equals positive 12. And multiplying everything in this second equation by 2, I get 6m plus 10n equals negative 6. And now I have my opposites, a negative 6 and a positive 6. So I'm going to go ahead and add my equations. Whoops. Negative 6 and positive 6, those are going to cancel out. They add to be 0, so I don't have to worry about my m anymore. Go ahead and cross them out. Negative 12 and positive 10 does add to be negative 2n. 12 and negative 6 adds to be 6. Going ahead and dividing both sides by negative 2, I get n equals negative 3. Now I'm going to choose either equation 1 or equation 2 to plug back into. Let's say I choose equation 2. Then I get 3m plus 5 times negative 3 equals negative 3. And notice that, I'm going to back up a step here. I'm choosing the original as opposed to the new equations, only because the original ones have smaller smaller coefficients, which usually means easier math. 3m minus 15 equals negative 3. Add 15. I'm left with 3m equals 8. 3m equals 12. From here, I'm going to 3m equals 12. I'm going to divide both sides by 3. My 3's cancel out, leaving me with m equals 4. Now that I know what m is, now all I have to do is write them as a point. Well, I don't know what to do. I'm familiar with x and y, but what do I do with n and m? We always go in alphabetical order unless we're told otherwise. So if I sing my ABCs, I notice that it goes m, then n. So I'm going to go ahead and write my point as m, comma, n. And there's my final answer. And that is the last example for elimination. So remember, substitution, it's easy to get a variable by itself, or there already is a variable by itself. Elimination, they're in standard form. So x and y are on the same side, and we get opposites by multiplying and then add our equations together.